Hello guys, this is Praveen studying BTech third year in Electrical Engineering in VNR Vignan Jyoti Institute of Engineering and Technology. On our way to break the boundaries between various disciplines of engineering, we have opted summer internships in machine learning applications in electrical engineering and done a project on power system fault classification using machine learning under the guidance of Dr. Rashmi Kapoor. Electrical power system consists of generation, transmission and distribution and utilization. We are utilizing all smart devices nowadays starting from smartphones to TVs and even smart refrigerators, etc. So, we should make our power system also smart. For that, we need to equip ourselves with new artificial intelligence techniques. For that, we have opted or completed Coursera courses on machine learning, which was provided by our institution just for free access. In our project, we have worked towards smart fault diagnosis systems in power systems. There are two main types of faults that occurs in power lines: series fault and shunt faults. We are concentrating our work towards detecting some shunt type faults in distribution lines. Shunt faults can be line to ground faults, line to line faults, double line to ground faults, or three phase faults. Generally, these faults are handled by microcontrollers based on relays and circuit breakers. To make our system faster, we want to make our computers as intelligent as a technician sitting in a substation who can just watch by or visualize the voltages and currents and can say the type of fault that occurs in the power system. There are basic steps need to be completed to develop a machine learning model. With these steps, we have used simulation tools like MATLAB or Simulink to develop a model for electrical distribution system. Now, implementation part will be explained by my teammate.
So this is the MATLAB Simulink model we have developed for electrical distribution system, and this model we have used this two workspace block to transfer the data from Simulink to the MATLAB command window, which is used for training, and this fault block is used to superimpose different types of faults in the system. If we will run this by superimposing a single line to ground fault, we will have this as the voltage and this is the current in the system, which indicates a faulty system. In this way, we have simulated different types of fault and different loading conditions, and after doing some pre-processing using Fourier transform and band power, we have generated this as our data set. The first 7 columns are the features and the last column is the target. 0 represent healthy system, 1 represent a system with line to ground fault, and 2 represent a line to line fault. And then by using this classification learner app, we have trained the system on the support vector machine type of machine learning algorithm. And this is the confusion matrix for the same, and it can be seen that the accuracy of the system is 100%. And now we are testing the system again by using the Simulink model of the system by changing the load conditions which are not used during the training. So I have changed the inductive reactive power QL in the load, and then I am superimposing a line to line fault in the system artificially, and then we'll check on our trained machine learning model whether it is able to predict the correct type of fault, whether it is able to classify the correct fault or not. So this has been simulated, can be seen by the voltages and currents in the system that the system is having a line to line fault. And now we are transferring these voltages and current to our trained machine learning model by using these two workspace blocks. And the M file return here will take the voltages and currents of the system, do some pre-processing on the input, and then it will predict the system or will classify the voltage and current in one class by using this PS fault, which is our trained machine learning model, using predict command. So yfit is equal to predict PS fault, input features, And then I have run it. It is showing that the system has line-to-line fault, which is the correct classification. Let us see one more case where I have a healthy system which is not having any fault superimposed on it, which can be seen from these voltages and the currents, which are both sinusoidal in nature. So this is a healthy system, and now when this data I am giving to my trained machine learning model for testing purpose or for getting inference, again it can be seen when I run this model, it is showing that the system is a healthy system.